Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is book back exercise question number 5.5 from NCERT textbook class 11 chemistry. Chapter name is Thermodynamics. So let's start the question. Number 5.5. Choose the correct answer. The enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are minus 890.3 kilojoule per mole, minus 393.5 kilojoule per mole and minus 285.8 kilojoule per mole respectively. Now find enthalpy of formation of methane gas, and they gave the four options. So friends, this is not the 1 second answer. We have to do some calculation. So let's start. How to do? What is the basic thing what we are going to apply is here Hess law. Hess law, what it says, Hess law says that the enthalpy change for the reaction is equal to the sum of all the enthalpy change of the individual steps taken to reach the main reaction. So here they are given three reactions as combustion of methane, graphite and dihydrogen. Fine, and we have to find the enthalpy of formation of methane. So we have to write all three equations. Then let's see what happened. So first reaction, what they are telling, methane, combustion of methane means CH4 in gaseous state plus oxygen gaseous state. That is combustion. Combustion means reaction with oxygen simply. It gives carbon dioxide gas plus water liquid form. Its enthalpy which is given is minus 890.3 kilojoule per mole. Fine. In the same way, we will write other two also. Combustion of carbon. Graphite means the carbon in solid state. We will write carbon in solid state. Now first, one more thing that we left. Balance the reaction as well. It will be 2 here and 2 here. We need a balanced reaction to follow the steps. Next is carbon and oxygen gas. Combustion of graphite, it gives carbon dioxide gas. Okay. Delta H for this reaction is also given, that is minus 190.5 and the unit is same, kilojoule per mole. Third reaction that they are telling is dihydrogen gaseous form plus oxygen, that is combustion of dihydrogen, it gives carbon dioxide, it gives water only. Gives us water, and balance the reaction, it will be half. Now delta H for this reaction also given, it is minus 185.8 kilojoule per mole. Fine. So these things are given. Now we have to find the enthalpy of formation of methane. First of all, understand what is enthalpy of formation. The enthalpy of formation is the enthalpy change when 1 mole of compound is formed. Remember, 1 mole of compound is formed from its constituent elements in their reference state, that is in their standard state. Now, so we have to make 1 mole of methane, that is CH4 gas, from their elements. Elements are carbon and hydrogen. Carbon, stable state is solid graphite, plus hydrogen, that is H2 gas. Now balance the reaction first. Correct. Now this is the reaction for the enthalpy of formation. Carbon plus 2H2, it gives CH4 methane gas, and we need to find the delta H for this reaction. So now what to do to reach this reaction using the above three reactions? Let's see. Simple calculation we will do. We need to get methane in the right hand side. Here in our reaction number 1, methane is sitting on the left hand side and both are having 1 mole. So we need not to increase or decrease the mole. We need only to change the places. So what we will do, minus 1, we will need to multiply the whole reaction with minus 1. Minus 1 on left hand side, it will make it positive on the right hand side, that we needed. Now carbon in the reaction number 2, carbon 1 mole in our main reaction, carbon is 1 mole and on the same side. So what we will do, multiplied by 1. The whole reaction is multiplied by 1. Next is hydrogen gas. Same side, so only we will multiply with positive number, and here it is 2. So we will multiply here in the reaction number 3, hydrogen is 1 mole, so we multiply it with. Now when after doing this change in the reaction, we will add all the 3 steps, and let's see we will find the final step or not, means the methane, formation of methane. Let's check reaction number 1. So what we are going to do, minus 1 multiplied by reaction number 1. Then we will do add 1 multiplied by reaction number 2. Then we will do addition of 2 multiplied by reaction number 3. Let's see, we are going to do this thing. So minus 1. So let's see, now we will write reaction number 1 with the same change, minus 1. So it will be minus CH4 minus 2O2. Fine. Now first we will write the left hand side, then we will write the right hand side. Leave the right hand side. Next is reaction number 2 multiplied by 1 only, plus 1. So it will be plus C plus O2. Clear? Now come reaction number 3, left hand side we are going to change. 2 multiplied by reaction number 3. So 2 into hydrogen, we will write 2H2 plus 2 into 1 by 2 means 1. So we will write O2. Now left hand side over, come up to right hand side, same changes. In the first reaction, CO2, that will be become minus CO2 and 2H2O become minus 2H2O. Now come up to second reaction, multiplied by plus 1. So CO2 in the right hand side, it will become same CO2, no changes, plus 1. Next come reaction number 3, right hand side it is H2O and multiplied by 2. So we will write 2H2O. Now let's see what should be cancelled out. Minus 2 plus 2 cancelled out, plus CO2 minus CO2 cancelled out. Look up here on the left hand side, 2O2 and this is plus 1 plus 1. So 1 and this cancelled out. Now see what is left over. Left over is carbon here plus 2H2 here and minus CH4, that we will write CH4 here. So now got our reaction. Using the 3 combustion reactions, we reached up to the formation of methane. It means our operation was correct. We will do the same thing with the numerical values of the enthalpies. Let's see. So what we have to do here is minus 1 into reaction number 1 plus 1 into reaction number 2, same we did, plus 2 into reaction number 3. Same we will do with the delta H, minus 1 into delta H1, that is for reaction 1, plus 1 into delta H2 for reaction number 2, plus 2 into delta H3, that is for reaction number 3. Now we have the given values. Let's write the value, minus 1 multiplied by delta H is, H1 is minus 890.3. plus 1 into delta H2 is minus 393.5 plus next is 2 multiplied by minus 285.8. Sorry, 8. Done. All the values are correct. Now get the answer. Will become minus plus become 890.3 plus this is minus. So we will write not plus. Now we will write minus over here. Minus plus minus 90.5. Now plus minus again minus. Now 2 multiplied by 285.8 gives the value 571.6. Now when finally we did our answer that came is minus 74.8. Unit will be kilojoule per mole, and that is our answer, which is the first one, minus 74.8 kilojoule per mole. So friends, that's all for today in this video. Hope you understand how to apply the Hess law. So friends, keep watching the channel. Don't like, share and subscribe the channel. Till then, thank you.